Hello, chemistry. Mr. McKee here, and I want to go over two-step conversion problems with you. I'm going to be working through some examples on pages 64 and 65 so you can follow along in the booklet. So if you take a look what I've got here, you can see what we call the roadmap, and using this roadmap we can convert from moles to mass or from moles to atoms. The first day of our conversions, we learned how to convert from moles to atoms, which was this part of the roadmap. And our second day of conversions, we learned how to convert from moles to mass in grams. And today we're going to learn how to do two-step problems. So as I was saying, in front of me here is the roadmap, and we can do one-step problems or we can do two. So a two-step problem is when you start with atoms, for instance, and in 1-2 steps, you convert to mass, or you could start with mass in grams, and in 1-2 steps, you can convert to atoms. All right? So I'm going to show you how we do that here, beginning with example 1. And as it says, we're going to convert from grams to atoms. So the question says, how many atoms are in 2.50 grams of chromium? So we're going from grams to atoms. So if I go back up to my roadmap, we're going to begin over here, and in 2 steps, we're going to convert to a number of atoms. So it's going to look like this, 1 and 2. It's helpful to have kind of a map of where you're starting and where you're going in your head. So we come back to our table, and I put my starting number and unit here as always, and I put my ending unit right here. And you'll notice I'm going to need 2 conversion factors for this because, again, we're going to start with grams and we're going to convert to moles, and I'm going to need a conversion factor for that. And then I'm going to convert from moles to atoms. And again, that's steps 1 and step 2 here. I'm going to need a conversion factor for each of those steps. So the conversion factor I use for the first one is 1 mole of chromium is equal to 51.996 grams. So that is my first conversion factor. And of course, I get that number 51.996 from the periodic table. For step 2, I use this conversion factor here, which is 1 mole equals 6.022 times 10 to the 23rd atoms of chromium. Okay, then we come down to the train tracks and we plug everything in. I put my starting number and unit right here, as always. And I'm going to use that first conversion factor to convert from grams into moles. So I put grams on the bottom, and that enables me to cross out grams. And at this point, I would have moles. But then I put my other conversion factor over here, and I put moles on the bottom. That way I can cancel moles out because it's on the top and the bottom, and I put atoms on top, and that leaves me with units of atoms, which is the goal. Now for my last step, I multiply everything across the top. So I take 0.250 right here times 1 times 6.022 times 10 to the 23rd. And then I hit divided by 51.996 and enter. I get this number in my calculator, but since my beginning number was 0.250 and it had 3 significant figures, I need to round my calculator answer to 3 significant figures. When I do that, I get 2.90 times 10 to the 21st atoms. So that is example number 1. So take a few minutes and do example number 2. Pause the video. Okay, welcome back. Hopefully you got through example number 2. One thing to notice about example number 2 is the answer, and I'm sorry, I'm talking about the you try in example number 1 here. The answer in your booklet is wrong. This is the actual correct answer, okay? So let me work through the you try here with you. It says, how many atoms are in 235.4 grams of titanium? So I have 235.4 as my starting number and unit, and atoms is my ending unit. So let's come up to the top here and kind of map things out. I'm going to start with grams, and I'm going to convert to moles, and that's going to be step number 1. And then I'm going to convert from moles to atoms, and that's going to be step number 2. And for each of those steps, I'm going to need a conversion factor. So for step 1, I need the conversion factor that relates grams to moles. For titanium, that's going to be 1 mole equals, and I'm going to check this on my periodic table, 47.867 grams. That's the conversion factor I use for step 1. And for step 2, I'm going to use 1 mole equals 6.022 times 10 to the 23rd atoms. And I'll abbreviate atoms with A there. So those are my 2 conversion factors. Now I start plugging everything into the train tracks down here, as always. 235.4 grams. I can put that over a 1 as a placeholder. And remember, in step 1, I'm converting from grams to moles, so I want to put grams on the bottom here using my first conversion factor. So I put 47.867 grams on the bottom, and I put 1 mole on top. And at this point, I've canceled out grams, and I'm in units of moles, but I'm not done because I want to convert to atoms. So now I'm going to do step 2. I'm going to use my second conversion factor here, and I'm going to put moles on the bottom because I want to cancel that out, and I'm going to put Avogadro's number, 6.022 times 10 to the 23rd, on top. Now I can cancel moles out, and I'm to my last step where I'm going to multiply 235.4 by 6.022 times 10 to the 23rd, and then I'm going to divide by 47.867, and the answer that I should get here is 2.961 times 10 to the 24th atoms. And you'll notice that my answer should have 4 significant figures there. So that is the you try for example number 1. Okay, let's move on to example number 2. If you feel like you've got this, of course, you don't have to keep listening to me. But some of you could benefit from an extra example, I'm sure. So example number 2, converting atoms to grams. Now we're going to go in the other direction here. The question is, how many grams of chromium would 12.5 times 10 to the 23rd atoms be? So we're starting with atoms, and we are converting to grams. Again, it's really important that you are clear about what you're trying to do. So now I'm going to map that out up here. We're beginning with atoms, and we're going to convert to moles, and then we're going to convert to grams. So step 1 is atoms to moles, and then step 2 is moles to grams. So for each one of those, I'm going to need a conversion factor. For step 1, the conversion factor is going to be, and I actually have these out of order here. So for step 1, we're going to need this conversion factor. So I'm going to write a 1 above it. And for step 2, we're going to need this conversion factor. So I'll write a 2 above it. So as always, we put our starting number and unit down here, 12.5 times 10 to the 23rd atoms. And we're going to convert from atoms to moles first. So I put Avogadro's number right here, and I can cancel out atoms. And then I convert to moles on top. So this again is my first conversion factor here. That's this guy right here. For step 2, I need to convert from moles to grams, so we put moles on the bottom and we can cancel it out. And that leaves us with grams on top, and this is my second conversion factor that I'm using. Then lastly, I times everything across the top and I divide down, and I get 108 grams of chromium. Okay, take a couple minutes and give this last example a try on your own. Pause the video while you do that. All right, welcome back. We're going to do this final example, and on this last you try here, the answer in your booklet was also wrong. So make sure that you change it to this. So let's work through this together. How many grams are in 5.4500 times 10 to the 26th atoms of titanium? So we're starting with atoms, and we are converting to grams. So let's map it out up here. We're going to begin with atoms. We're going to convert to moles. Moles are going to always be in the middle on these two-step problems. And then we're going to convert from moles into grams. And we can think about it like this. Step 1 is atoms to moles, and then step 2 is moles to grams. So my starting number and unit is 5.4500 times 10 to the 26th. My ending unit is going to be grams, and I forgot to write atoms here. I'll abbreviate atoms with an A. I apologize for my handwriting. My first conversion factor is going to get me from atoms to moles, so the relationship between atoms and moles is 6.022 times 10 to the 23rd atoms equals 1 mole. So that is conversion factor number 1 that I use for step 1. For step 2, I need to know the relationship between 1 mole of titanium and its mass. So 1 mole of titanium is equal to 47.867 grams. And that is the conversion factor I'm going to use for step 2. Now we plug everything in here. Put my starting number and unit down here, 5.4500 times 10 to the 23rd atoms. Put that over 1. And I'm going to multiply by my first conversion factor 1. And I'm going to put atoms on the bottom so that I can cancel it out. And I put moles on top. And that allows me, again, to cancel out A for atoms here. Now I'm going to put my second conversion factor right here. I'm going to put moles on the bottom. And I'm going to put 47.867 grams on top. That allows me to cancel moles out and leaves me in units of grams. Last step, I times everything on top. So I've got 5.45 times 10 to the 23rd times 47.867. And then I divide down, and I divide by 6.022 times 10 to the 23rd. And I want to have my answer shown with 5 significant figures. And so the answer is 4.3378 times 10 to the 4th grams. That's what you should end up with. Okay, if you have any questions, I'll help you out tomorrow when I get back. Otherwise, I hope that helped. Have a great day. Talk to you guys tomorrow.